Hello everyone. Thank you very much for joining this training today on the Beginner's Guide to Storage Spaces Direct. My name is Clint Wyckoff. I'm a Microsoft MVP and I'm joined by my fellow Microsoft MVP, Dave Kawula. So again, thank you very much for taking a time out of your busy days to join us. Before we get to the content at hand, we're going to take a very brief look at what we're going to discuss today. The first piece that we're going to dive deep into is the Storage Spaces Direct infrastructure. The next area will be how to exactly build your very own Storage Spaces Direct environment. Maintenance, very important, so we'll be touching on the topic of maintaining your Storage Spaces Direct cluster, as well as leaving time at the end here for some questions and answers that will be answered live via the GoToWebinar platform. Before we kind of dive into things here, it's important for everyone to understand the background of what Storage Spaces Direct is, what operating systems are, kind of utilized here, what is the core networking components, as well as the typical prerequisites. So, before you really start to peel back the onion and look at, the underpinnings of what Storage Spaces Direct is, it's really important for everyone to understand that this key functionality ships directly with Windows Server 2016. So if you're licensed, via software assurance, or you have Windows Server 2016 licenses or, operating systems deployed inside your environment, specifically the data center edition, this functionality ships with the product. It's built into the kernel. Several of the main use cases that Dave and I are going to discuss today are focused around Hyper-V. So it's baked into the kernel of the operating system. So, how does this actually work? That's a really great question that we get all the time from the field. And the first piece, that is important to really understand is the fact that this is a hyper-converged solution, meaning the fact that this runs on bare metal hardware, commodity hardware, and it requires absolutely zero SAN. So from a Microsoft perspective, you deploy the operating system, Windows Server 2016 on a JBOD type solution, just a bunch of disk. There's absolutely no requirement for any external SAN devices whatsoever, and it follows that shared nothing kind of methodology that we're seeing out in the field to be very popular today. So, there's a lot of different vendors out there that you might purchase your servers from. You could use Dell, you can use HP, you can use Cisco UCS. There's several others out there as well. Lenovo is one that we're going to talk about today specifically. But it's important to realize that this runs on these industry standard servers with internal drives. So as we dive into storage pools and volumes and actually creating your first Storage Spaces Direct cluster, everything that runs inside of this environment runs on these internal drives. There's no requirement for any external SAN whatsoever. So in order to ensure high availability, in a Microsoft world, this is done via Windows failover clustering. So in order to build our Storage Spaces Direct cluster, we are going to cluster those together using Windows failover clustering. So with that, as we kind of build this out inside of a Storage Spaces Direct, and we have some sample PowerShell that we'll share with you here throughout the course of this training exercise, we're going to create this software-defined pool of storage that expands across all of the nodes inside of the cluster. And in this case here, we have a 3-node cluster. So once we have this pool, the fastest disk in the pool, typically that is either NVMe or SSD drives, they are pulled together to create the caching tier. And then there's also resiliency that's built into this product as well to make sure that all of the data that is written to disk, should a node or a rack or a cluster, fail, all of this is configured automatically as part of creating your Storage Spaces Direct cluster environment. Now, at this point that we have, our 3-node cluster, we've created the volumes, we've created the pools, let's move forward here and actually show that how this actually has the built-in resiliency. So, if we simulate a drive failure inside of my cluster, or even an individual host failure as well, or perhaps, I have a massive, multi-node, multi-rack deployment, what if I have an entire rack of servers or a PDU inside of that, that rack go down, causing everything, to go offline? Well, fear not, because all of your data stays online and accessible via, the parity bit or the RAID configuration that is defined inside of the storage spaces direct environment. Some of the similar use cases that we're seeing here, you can deploy, storage spaces direct in a converged infrastructure type environment. Even though the solution itself is a software-defined SAN, you would deploy a scale-out file server role on here. And then you would connect that scale-out file server to your external Hyper-V cluster. So that's kind of one of the use cases there. The second use case where you're able to run all of your virtual machines, including the Hyper-V role on top of storage spaces direct, is the hyper-converged deployment model. So there's two different flavors that this comes in, all of which is able to host virtual machines live running, production mission-critical applications and services without any performance degradation or loss of resiliency or integrity or any of those types of factors that are important inside of today's enterprise data centers. It's really important for everyone to understand that, yes, there is a lot of different commodity hardware out there, and several of the vendors are actually going through and pre-certifying their reference architectures. So if you yourself wanted to, kind of veer off that beaten path and go with your own deployment, how can you validate that this is actually, a certified solution from Microsoft? And that's really where the Windows Server software-defined program comes into play. So if we come over to here and we show you exactly what this looks like, it's just a URL in your web browser, and we'll share this deck with you afterwards. And it focuses on, the goal of the program being the fact that it wants to ensure that all of your customers have a seamless deployment as well as experience on validated hardware. And if we scroll down here on the web page, we can see, the different offerings being a hyper-converged, the converged infrastructure, and then it even shows you the exact steps that you need to go through to certify and validate that your hardware configuration is in fact, minus the logo being Windows certified, is certified by Microsoft. It tells you exactly how long you need to perform the activities for. I believe if we were to go down here a little bit further, it shows you stress tests. So they even give you sample scripts and things that you can run. You can even come over to here and say, I want to run this step for 96 hours minimum and maximum, and then it even tells you exactly what you should expect. Associated hardware, software, if this is a brownfield environment, if it's a greenfield deployment, this is something that you, as you're building out your storage space direct clustered environment, you want to make sure that it's certified by Microsoft. This will be a handy URL to bookmark for sure. So if we pivot back over here, and, a lot of the other different vendors out there, so you have Dell EMC, they have white papers as well as reference architecture documents that show how to run, Windows Server 2016 storage spaces direct on, Dell hardware. Our friends over at Lenovo, they also have reference architectures as well, and they can show you how to run this not only from a hardware, a CPU perspective, but also from a networking perspective as well, which network interface cards you need to purchase, how much memory, and you can be sure to check that out if you're a Lenovo fan.
Hey, Clint. Just to jump in a bit more on the Dell and Lenovo solutions that are out there. One of my favorite parts about those two solutions is the fact that they actually give you reference build architecture. So what that means is they're going to give you step-by-step guidance to actually build this in your data center. And Dell specifically, I've had the chance to work with one of their very first Dell EMC ready storage spaces direct builds at an enterprise customer over the last couple months here. And it's really interesting to see how that program works. So for example, we have a lot of challenges in the field with building any of these solutions and finding and maintaining things like driver and firmware updates and versions and revisions and all this thing. Like, for example, if you're building this on your own, you don't know that version 14B of the driver is supported, 14C doesn't work, right? Because there's some bug in it or some issues or whatever. What Dell has done is they've actually gone through the full certification program with Microsoft, and they've actually published all of their build documentation to go with this. So you can either build with System Center Virtual Machine Manager, or you can build in a standalone configuration, and that document actually lists everything you need to know step by step by step. And then when you take a look at Lenovo, Lenovo was the very first one to actually release one of those pre-WSSD certification. And we actually, a lot of us in the community actually use that as a good kind of framework and reference guide. And the latest one that's come out is from our good friends over at Mellanox Technologies. And one of the things I love about their solution, same as Dell and Lenovo, is they're actually publishing all of the top-of-rack switch configurations that are required to make all this work. And that's something that can be actually very challenging because you get bits and pieces of how to set this up and how to configure it and what does this really look like. And the guys over at Lenovo have supplied that. They've supplied the PowerShell scripts. So have the guys over at Mellanox. And this makes a really great community experience because you know that if you're buying that hardware that is on that certified platform, you're going to be able to make it work. And if you happen to buy hardware prior to the certification, as long as you maintain the firmware levels, the driver levels,
Supported.
Everything should be good and you should be supported, right? And it makes your experience with Storage Space Direct a lot smoother. And that's the biggest issue that we've had from the field is wrong driver versions, wrong firmwares, customers trying to use not supported parts. So you just really need to make sure that you stay within that supported platform to get this going. And we're going to give everybody that's attending this course a really cool little gold nugget in the third session coming up today because we have 3 sessions today. And we're going to actually show you how to build this in your lab. Even if you don't have certified hardware, we're going to show you how you can get this spun up in your own very lab to test this, play with this, and get familiar with it.
Yeah, definitely. And especially, if you want to contact support for assistance, making sure that you're running a certified configuration with the right, not only the right hardware, but also the right, as Dave mentioned, right firmware as well as the correct drivers on top of that. So those are the kind of the most important pieces of the puzzle. And, what we've seen in the field, and specifically inside of the MVP community, a lot of the deployments of Storage Spaces Direct that have problems are associated with either bad hardware, bad firmware, or bad drivers. So making sure that you're utilizing these reference architectures that we're giving you today, if you use a vendor that we didn't perhaps mention, you should definitely ask them, for their reference architectures that are certified, Windows Server 2016 certified for Storage Spaces Direct. So, lastly, our friends over here at MVPDays, being Dave as well as Thomas Rayner and Alan Rayfuse and Crystal, they've actually written a book totally around mastering Storage Spaces Direct. So you're getting the information, directly from the source that is an subject matter expert on the topic. And you can head out to Amazon and grab your copy of that at your leisure. So, some of the things that we're going to kind of really dive into a little bit further in, Module 2 as well as Module 3 of this training exercise with you today, is the big demo script that Dave has out there on his GitHub site, as well as some of the different things inside of MS Premier and what they have on their GitHub site, and even some of the different Azure Resource Manager templates that are available inside of Microsoft Azure that are focused around Storage Spaces Direct. So these are more, lab type exercises. I want to kick the tires on Storage Spaces Direct, see what it's all about, run it inside of a lab environment. Maybe not necessarily the greatest for production, but definitely if you want to, do a small POC or proof of concept of the overall solution. So, kind of the secret sauce here being the networking. Even though we talked about, Lenovo, we talked about Dell, we talked about shared nothing storage, individual Hyper-V nodes inside of a failover cluster, what makes all of that kind of work together? And really the most important piece here being that RDMA, or that remote direct memory access network interface card. And that's really the special sauce that allows all of that data to transfer directly to or from the application memory from node to node. So there's literally no external SAN devices, and all of that data and integrity is being transferred from node to node via the network interface cards. So RDMA is one possible way. Another way that we're actually seeing folks in the field deploy these and is fully supported being the RDMA over Converged Ethernet. Talking to an expert, they might refer to this as Rocky. So what this actually allows you to do is use traditional copper Ethernet twin-X cables inside of your infrastructure and still get kind of that InfiniBand support. So what this does is that it translates that InfiniBand over the Ethernet network, and all of that traffic, that InfiniBand transport protocol is, sent over in just traditional Ethernet packets. And some of the different supported configurations that we've seen folks leveraging, in the field that again is fully supportive is the Mellanox Connect X3 Pro Rocky, and this has really proven an efficient RDMA transport for providing the platform as well as the RDMA technology in those mainstream applications. And it's not just limited to 10 gigabit Ethernet that you would traditionally kind of see inside of today's enterprise, but you're also able to get even up to 40 gigabit Ethernet link speeds. So this is really something that if you're looking at building an extremely next generation, high performing storage spaces direct cluster, this is really where you want to spend, a good bit of your time investigating and doing your due diligence and making sure that you're deploying a fully supported, configuration.
Clint, with that configuration as well, the Mellanox adapters may be new for a lot of people that are attending the training here. So the Mellanox adapters are actually the certified adapter of choice for the Dell EMC Ready configuration, as well as the Lenovo configuration and a lot of the others that we've seen out there as well. So I'm doing some HP builds right now, and it seems like Mellanox seems to be the standard adapter that most are going with here today. And I don't know if you guys check on Microsoft's website, they have a whole bunch of statistics on exactly what Storage Spaces Direct can do. And one of the principal program managers for the storage team, Klaus Jorgensen, actually did a demo at, I think it might have even been Ignite last year, and they were showing off some of the brand new 100 gigabit Ethernet adapters, and they were pushing, I think, 60 gigabytes per second through their Storage Spaces Direct cluster, which is absolutely insane for the amount of throughput that you're getting across the wire.
Yeah, that's pretty wicked. Just because you can doesn't mean you should all the time, but definitely, something for folks to keep in their mind as they're building out these different Storage Spaces Direct configurations for sure. So, I think at this point, Dave, we're actually ready to pivot over to a demo. I'm pretty sure you're going to give us a demonstration of some different top-of-rack switch configurations, core networking, the RDMA, as well as validating the RDMA connectivity, and I think you even have some hidden nuggets in there for us also, right?
Yeah, we have an amazing demo. One of the things that has really never been covered before in any of the sessions that I've seen is configuring Storage Spaces Direct, Clint, on live physical hardware. Not in a lab environment. Well, it is a lab environment, but not in a nested virtualization environment like in VMware or Hyper-V. This is something that we're going to actually build this out on real hardware. And the reason for that is if you want to play around with RDMA, data center bridging, your top-of-rack switch configuration, the unfortunate reality is you kind of need a bit of hardware. And so I have to give a big shout out to our good friends over at Mellanox. They provided me with a full demo kit for a couple courses, and this is one of them that we're doing just for you guys. So we actually get to see some next generation networking gear, their latest version of network adapters. We're actually going to work with the CX4 network adapters, which is one step up from the CX3. And it's really cool. They shipped that entire lab kit out just for you guys and in the community, right? So we could actually showcase all this. So that's very cool. And thank you guys very much at Mellanox for taking care of us there.
Yeah, definitely. Thank you very much. We greatly appreciate it. And I'm sure you, the viewers that are with us here today, will enjoy it also. So at this point, let's take a look at the demo.
All right, so let's get started with our build of Storage Spaces Direct. One of the things I wanted to showcase in this particular training session that we're doing is how to not only build this in a lab environment, but also how to do a production build. So I'm happy to tell you guys that for the very first time in one of my Storage Spaces Direct presentations, demos, trainings, anything that I've delivered around the world, I'm actually going to build a live 2-node Storage Spaces Direct cluster, and I'll even show you guys what it looks like from a hardware perspective for, you know, what it is that we're going to be building here. Now, my lab environment, I have some repurposed hyper-converged infrastructure that we're using, and it actually works really well for Storage Spaces Direct. Even although it's not on the WSSD certification list, all of the components are, and so it actually installs and builds great for my lab environment. Now, unfortunately, I don't have enough money for my lab environment that we're going to be building on here to showcase a full NVMe flash configuration, multiple tiers of storage and stuff like that. So I've got one base tier that we'll have with all flash, and I've got a mix of a couple enterprise solid state drives in each of the servers and some commodity drives in there as well. Now, the commodity drives aren't recommended for a production build, but it at least allows me to show you what the process will look like for the production build. So why don't we get started by taking a look at our hardware configuration here. So first thing we'll do is we'll log into the IPMI interface on one of my nodes here. All right, so we're already logged in. Now, the nice thing about the Supermicro chassis is that even if you don't know what your IPMI interface is, you can actually click on Server Health and you can click on Multi-Node Configuration. And this will actually give us a good description of the type of hardware that we're building on here. So you can see that our system model that we've got is an 2028 TP HC0TR. See the system serial numbers. But the cool part about this is one of the 4-node hyperconverged chassis. And inside of these hyperconverged chassis, we actually fit 4 servers into a 2U configuration, and they actually don't share anything except for a shared power supply as a backplane. Each of the nodes are independent with their own storage controllers, their enclosures, and so on. So one of the things that I like about this particular interface is that sometimes I forget what my IPMI, or if you're a Dell person, it might be an iDRAC configuration, or for HP, it might be ILO. It's your out-of-band management network. So sometimes I forget what those IPs are. So I like this particular configuration on the Supermicros because I can actually see the IP addresses of the other nodes that are configured. So I can see that I've got node C configured at 192.168.1.90. I've got node B configured at 192.168.1.247, and I've got node A configured, which is our current node. So let me close down this window, at 192.168.1.61. And so I can jump around between the nodes this way quite easily, and I have full access from a power management and power control. Now, what's going to be cool about the training that I'm going to show you here this week is we're going to use this IPMI interface to actually simulate what a hard power failure is going to look like inside of a Storage Spaces Direct environment. So one of the things that we can do in here, if we come over to our remote control, we have a power control button here, and I can actually turn off the server the same way that you'd be able to do on your Dell, HP, Lenovo, any enterprise grade server. So a lot of hyperconverged solutions that are out there today they don't survive very well in the event of a hard power failure. So for example, what I'm talking about is your UPS batteries fail you. You just had a brownout or a blackout on your power grid, and your servers just go down hard. There's no start shutdown, safe shutdown process. I'm talking about going down hard. Now, there's going to be some of you that are listening right now, and you can go into the chat window and just let us know if you've ever experienced anything like a UPS battery failure, or if you've ever experienced a PDU failure, because you know what, guys, I sure have, and it's not a very fun process to recover. The cool part about this is Storage Spaces Direct is actually really resilient, and we've seen multiple instances around the world for production configurations that we've done, not only in testing, but in actual raw failures, where we've had zero data loss so far in any of the systems that I've worked on so far. So I think that's pretty cool. So we'll come back to this IPMI interface here a little bit later on. And I think the next thing I'd like to show you here is the top of rack switch configuration that we're using. So let's go to our Mellanox switch configuration here. And I have to give a really big shout out to the guys over at Mellanox, because my lab is actually powered by 100% Mellanox networking gear right now. And they've actually let me use this gear on loaner so that I can work with and test their Storage Spaces Direct solutions. So big shout out to the guys at Mellanox. Thank you guys very much for providing me with the lab gear to get this done. It's very cool because now I get some enterprise grade gear that we can work with. Now, if you take a look at the picture of the switch I've got, this is what's called a S1012X switch from Mellanox. And these switches are actually really cool. So if you take a look and you count the number of ports on there, you can see that there's 12 total ports on there. So those are 12 40 gig ports. And so those 12 40 gig ports that are on there can actually be split 4 ways using what's called a hybrid cable from Mellanox technology. That hybrid cable can actually take and split those 40 gig ports into 4 independent 10 gig ports. So what you'd see inside of the UI, if I was actually using those hybrid ports, is slot 1 would actually be cut into 4. And you can actually hook 4 servers up to that in a 10 gig configuration. So even this little switch that you're looking at, it can actually be configured as a 40 gig, or sorry, as a 48 port 10 gig switch configuration. You got to check out this switch. It's the S1012X. I did some pricing. I hate to just talk about pricing in any of these presentations, but you guys can check this switch out. The switch is listed up on Amazon, and just check it out. You won't believe the price point when you see it. It's probably one of the most affordable top of rack enterprise grade switches that you'll find out there. Super easy to configure. Configures just like a Cisco switch. So let's take a look at what we did with this. So I've got 3 nodes configured. Those 3 nodes that I have configured each have 1 port connected into 2 distinct switches. So these 2 distinct switches I have are actually sitting side by side. So if you could visualize this, I had one switch here, I had another switch here. Ports 11 and 12 are my cross connects. So those are my trunks, ether channel, whatever you want to call them, between the 2 switches. And those are both running at 40 gigs a piece. So I've got 80 gigs of backplane throughput between the 2 switches. And then what I've got is I've got a teamed configuration where I've got port 1 on NIC 1 on my Mellanox CX4s connected to port 1 on either switch, right? So they're cross-connected, highly available. I could completely lose one of these switches inside of the fabric, and my Storage Spaces Direct configuration would not go down. All right, so let's take a look at our actual configuration that we've got. So I wanted to show running config just to show you how easy it is to configure your top of rack switches for Storage Spaces Direct. When we take and configure these, there's actually not a lot that has to go into them from the configuration requirements for Microsoft's hyperconverged storage. So if you take a look at my interface configuration here, what you can see is that I've got port number 1 through 3. Now, one of the things I did note in this particular configuration is that I had to force the configuration here for 10 gig because it was trying to default to 40 gig and it just wasn't coming online properly. The second thing that you'll notice is that I've got jumbo frames enabled. So that's why I'm changing the MTU size on each of these ports. And then the rest of the ports are just unconfigured at this point in time. So these are just set up as hybrid ports. And so the hybrid ports are basically what Mellanox considers a trunk port. And so then if you take a look here, I've got a channel group set up, and this is where I'm cross-connecting the two switches. So I've got one channel group on ports 11 and 12. And then you can see my VLAN configuration. So as we learned earlier this morning in our configurations, in the trainings, there are published configurations available from Mellanox Technologies, Dell EMC Ready configurations, Lenovo configurations. And so what I wanted to do for this particular demo is I wanted to give you something that you could follow along with at home. So this switch configuration that you're looking at actually came directly from the Mellanox Storage Spaces Direct Configuration Guide that I talked about in the training earlier. So you guys can actually grab it right from that document and you guys can build this yourself. I even kept the VLAN IDs the same so that everything would kind of flow nicely for the training. So you can see I've got a few VLANs configured for a Hyper-V environment here. I've got a management VLAN on 616. I've got a cluster configuration on 617. Live migration on 618, storage network 619, and then I just have a deployment network, which is actually unused at this time in the lab environment on 621. Okie dokie. Now for the good stuff. This right here, the DCBX PFC, Priority Flow Control configuration, this is the actual secret sauce for the lossless configuration that you're going to configure for these S1012X switches. These are going to be pretty much the same on any of the switches that will support Storage Spaces Direct. A couple of things you have to note for the switches to support Storage Spaces Direct. They have to support a feature called Priority Flow Control, or PFC. And they also have to support ETS as well. But these 4 lines are going to be the configurations that are actually going to match up on each of the nodes. So the DCB configurations, or data center bridging configurations, are actually an option inside of Windows Server 2016. And we have to make sure that we take and we match these settings on our individual servers. So when we go through the raw configurations, you're going to see there's Windows configs in PowerShell that are going to match up to what the switch configuration has. Now, I know you're asking yourself, for the use cases of Storage Spaces Direct, what if you just want to get this set up in your lab environment and you didn't have a couple friends at a vendor that gave you some gear so that you could actually stand this up? It's not a problem. You can completely configure Storage Spaces Direct without using RDMA or Rocky configurations, or as we learned earlier this morning. They work fine. It's just you're going to take a little bit of a hit on your CPU and memory utilization on those individual hosts. Plus, you're going to be seeing a lot of additional traffic flowing across the network. Okay, so that's pretty much it for our switch config. I can just scroll down and just show you what the rest of it looks like. And for our handouts, what I'm going to do is I'll actually provide a copy of the switch configuration that we used here today for this lab build, just so that you can have something for an example. All right, so what do you guys say we get into the actual configuration of these nodes and build out our very first physical Storage Spaces Direct cluster? I think that's a fabulous idea. Okay, so for the configuration that we've got here, a couple things that we want to take a look at doing as prerequisites. Number one is I found that the Dell EMC Ready Storage Spaces Direct Configuration Guide was really good because it had some great reference architecture pieces in there to list out some of the things that you're going to need. Like, for example, your server names, your VLAN configuration matrix, your network configuration topology, all of those pieces that are really going to be required for an enterprise design. Okay? So that's a great starting point for you when you're building your reference architecture for the solution. Now, for my build that I'm going to show you here today, we're going to take and we're going to build this with 2 nodes. Even although I have 3, I'm actually using the 3rd node as a management server right now. So we're just going to do it with a 2-node build. The process is pretty much the same. You can actually walk this all the way up to 16 nodes if you really wanted to. One of the most important pieces that we found from the field, and you come to these sessions here today to try to pick up the gold nuggets, those little pieces of information that you're going to take away that are going to save you a ton of time, save you all that pain and all that additional effort of going through and troubleshooting the solution. Number 1 key rule when you're dealing with a technology like this from Microsoft: make sure that you stick within the certified hardware platform. Don't stray from it. All of that stuff has been tested. We know it works. We know the configurations are good. The second thing is, Dell's actually taken this one step further, where they've actually provided a what's called Dell EMC Ready solution for Storage Spaces Direct. And they actually publish a reference matrix architecture, reference matrix guide that lists all the firmwares and all the driver version numbers that are currently tested for the solution today. Please do not go jump on the brand new latest versions of the firmware that the vendors are putting out. My good friends at Mellanox, we actually have a couple issues with some of the newer firmwares that have been released right now. And we're really struggling in the field to try to figure out some of the issues. Sticking with the tested platform has actually worked really, really well for us. So just a word to the wise, a cautionary tale for you guys. Don't just go jump and start upgrading your firmware once you have this all up and running and functional. Make sure that it's been tested, make sure that it's been validated, and even although it may have a logo supported sticker, reach out to the community and see if anybody has actually used that particular firmware, driver, version, release, anything like that. Now, the place that you can go from a community perspective is here. So what you want to do is just go onto Twitter, and you want to follow these 2 hashtags. Hashtags Storage Spaces Direct or hashtag S2D. Ask your questions there, all right, before you get started. It'll save you a ton of time, and trust me, it's going to be well worth your while. The configuration that I've got in my lab, we took a look at my physical hardware already. The network infrastructure that I've got those S1012X top of rack switches. And Mellanox has also provided me with their latest brand of network card, which is called a CX4. So their CX4 cards are fully certified with Storage Spaces Direct, although that Dell solution we were mentioning earlier has actually only been certified on the CX3 Pro lineup. Because remember, it takes the vendors a little while to catch up to get these certified solutions out there. So if you want something that's been completely vetted, stick within that supportability matrix. All right, so we've got CX4 cards. And one of the things I always like to do before we take and get started with the build like this, because there's a lot of networking components and there's a lot of things that have to go in behind the scenes to build this out properly, is I want to check the firmware versions of my NICs, okay? So there's a little utility that you can download from Mellanox's website called MST. Okay, so this is an installer that you have to actually download from their site. It's free. Just go on their site, search for their firmware tools for the cards. This is just one of the installers that comes. You need to install this on each of your nodes. All right, so let's just get a little bit of information about these cards. So the first thing I'll do is I'll run a command from Mellanox called MST status. Now, what MST status is going to return for me is the list of Mellanox technology cards in this particular server. This is really important because if you take a look at the return results, I can see that the card is an MT4117. Now, we have to enter that in the next line for their second utility, which is called Flint. Flint is the Mellanox utility that's used to burn firmware. So if you want to update the firmware on these Mellanox cards on a production build server, Storage Spaces Direct, Flint is the utility you need, but you need to figure out what the model of card is that you want to go talk to. So what we're going to do initially is just run Flint with a Q switch And this is just going to bring up some information about the current firmware that's currently installed on this particular box. And remember, just because you ordered a batch of cards from the manufacturer doesn't necessarily mean that all the firmwares are going to be up to date and the same. So you can see that this firmware is already a little bit old. So this firmware is from the 22nd of November, 2016. And the model number here is 14.17.2020. All right. So now the current firmware that we've got is 14.18.2000 right here. Okay. 14.18.2000. Now you're asking yourself, why do I have this line of firmware commented out? Well, the answer is simple. I put the newer version of the firmware in this particular lab build, and I actually had issues with storage space direct. Now, Mellanox still hasn't had a chance to fix said issue yet, so I'm sticking with the older version of the firmware, and that seems to be working very well for us in the field right now. All right, so this has probably been my #1 biggest issue that I've had with building production storage spaces direct farms in the field to date is firmware issues. So something that should work in one version, you think it's going to work in the next, make sure you go through all your testing cycles. So as you can see, I'm actually keeping on the older version right now. But if you wanted to update this, all that you have to do is just run flint-d, identify your card number. It's I to install, and then just the path to the bin file. The bin file is a free download from the Mellanox website. And then you just do a burn at the end of this. So for the sake of time for the video today, I'm actually not going to show you that, but it's well documented up on the Mellanox website. All right, so let's assume that everything's good. We have just some vanilla servers that we're dealing with. So the very first thing that we would want to do is we'd want to put some roles on there. Remember, you've just installed from your gold image. So your gold image is basically going to be fully patched, fully serviced, all the drivers updated, everything's good to go. So it's like me as a consultant walking into an organization and them handing me their gold build saying, Dave, go do what you need to do. All right. So now the next thing I have to do is put some of the roles and features on these boxes that are going to be required for the build. Now to use storage spaces direct, remember, it's really cool because storage spaces direct, do you actually see it here as a role or feature? No. So I thought that was the whole point of this training video, wasn't it, guys? Was for us to actually go ahead and configure storage spaces direct, yet it's not a role or a feature. Why is that? The answer is really simple. It's because it's embedded inside of the kernel. It's in the operating system already. You don't have to do anything. You just have to activate it and use it. So it doesn't sit as a role. It doesn't sit as a feature. It's already there. Now, there's a couple of prerequisites that we have to use this and get our underlying infrastructure set up correctly. And that's getting that data center bridging piece configured, which we already talked about with the top rack Mellanox switches. I've added file services here just in case I want to set up a scale-out file server as part of this configuration later. We need failover clustering because that's what drives storage spaces direct high availability between the clusters. And then we have Hyper-V. So if I want to set this up as a hyper-converged solution, you need your hypervisor installed. And obviously it's Microsoft solution, so Hyper-V is going to be the hypervisor that's going to be presented here. So let's say we've actually done this, all right? So I'm not going to do this as part of our lab build. This is actually the only thing that I've staged because this stuff is pretty rudimentary to actually go through and install. It's just, it takes 2 reboots to actually install the Hyper-V role. So I didn't want to wait for 2 reboot cycles on physical hardware to occur before we continued. So we're just going to assume that my S2D 2 and 1 nodes are already pre-configured with these roles. And we're going to start from right about here. All right. So we've got our roles installed. Pretty straightforward so far, right, guys? I think so. Now, a couple other notes in regards to the Windows updates. You need to make sure you stay on top of this because Microsoft is actually releasing hotfixes for storage spaces direct in what seems to be most of the cumulative updates that are coming for Windows Server 2016. So you want to make sure that you're taking and you're kind of falling in line with this, okay? So make sure that you're staying up to date with your patches. So first thing we're going to do, this is a nice little trick for configuring multiple nodes here, is we're just going to take and we're going to configure S2D1 and S2D2 So I'll just define an array here that's called nodes, and we're going to use this a lot going through the script. Okay, so it's just going to add those 2 nodes into an array. The next thing that we're going to do here is we're just going to get a list of the installed Windows features, just make sure that we've got Hyper-V and everything installed in these nodes. So if I scroll up here, let's pick Hyper-V for example, and I can see I've got some RSAT tools for Hyper-V installed there. And we've got the Hyper-V core role installed here as well, okay, on both of the servers. Failover clustering, everything's done. So we're going to assume that that's good. Checkbox, everything's done properly. The next thing that we're going to want to do is we're going to want to configure jumbo frames on those Mellanox adapters, okay? So in order to do this, we're going to run the next line of the script here, which is going to configure this. Now remember, if you're following along at home, I gave you a copy of this script as part of the handout, so you guys can actually just kind of follow along to see what's happening on your own machines, all right? So we'll just go ahead and configure this to enable the jumbo frames on our Mellanox adapters. So that's done. The next thing that we're going to do is start to actually work through our data center bridging configuration. And this is done through what's called a net QoS policy, a net QoS or quality of service policy. And we're going to define a special policy for all SMB traffic, which is what Storage Spaces Direct uses. So you can see we've got the SMB port on 445. And then we're going to set some priority values inside of here as we go through and configure this, as well as configuring our flow control. All right, so let's go ahead and let's enable this. And these are pretty universal settings for most RDMA Rocky configurations for Storage Spaces Direct. So configure our first one, which is just our policy. Perfect, it's done. The next one is just going to set the priority on that traffic of 3. And then we're going to disable all net QoS flow control policies on the rest of the types of traffic. After you configure these policies, you have to apply them. So the next line here is basically going to take all of my interfaces that match Mellanox and are going to take and apply that policy that we just created above. So that's simple. And you're wondering why we're doing this in PowerShell? It's actually the only way to configure this right now. There's no GUI or UI-based interface for this. And then the last thing we're going to do is we're going to give a minimum bandwidth percentage of 50% to that class of traffic that we've now defined. Perfect. So from a mask configuration perspective, as we're going through and setting this up, I have scripts that'll just rip through and configure nodes in a matter of a couple minutes. What I've done here today for you guys is I've broken down these scripts so that it's basically going to be on a line-by-line basis for the entire configuration for these sessions. So this particular session that we're going to be having for our first one here, we're going to focus on the networking configuration. The next set of demos we have will actually stand up Storage Spaces Direct and the failover clustering. So the next thing that we want to do is we want to enable our net adapter QoS on those 2 particular adapters. So if we just come over here, let's take a look at our adapters. We can see Ethernet 5 and 6 here. Those are my ConnectX 4 LX adapters from Mellanox. Okay. All right. So the next piece that we'll do here is actually, let's look at the configuration that we have across each of the nodes. Now, it's funny for my lab. I grabbed a switch off the shelf for the lab for my management network. Can you see the mistake that I made here, folks? I grabbed a 100 meg switch instead of a gig switch for my management network. I was trying to figure out what was wrong with my lab for the longest time, and then I realized that one of the guys had actually grabbed me the wrong switch. Fun stuff. All right. Now we're actually ready at this point in time to configure something called a switch embedded team. So now I think that you guys have probably at this point in time worked with traditional teaming inside of Windows Server 2012 or 2012 R2. So traditional teaming, you actually had a user interface for where you could go in through Server Manager, you could enable your team, you could enable it as a switch independent team, or you can enable it using link aggregation or LACP. Now with Windows Server 2016, they've added a new team type. The new team type is called a switch embedded team. And that's what this little setting here does, called enable embedded teaming. The big piece for this that's changed for a switch embedded team is that in prior versions of Windows 2012 R2 and 2012, we could actually use RDMA in those versions, believe it or not. The problem is we couldn't use RDMA over a teamed interface. So we had no high availability, no redundancy. So in order to use that new piece of functionality, we actually have to use this switch embedded team. So we'll go ahead and we'll create this. Remember, there's no UI for this. So if you go check in Server Manager, it'll look like you don't even have a team created here. So we'll just go ahead and press F8 and we'll run this. Cool part about my script is you'll notice how I'm actually configuring both nodes here at the same time. So if you had 16 nodes in your cluster, all you'd have to do is just change the nodes up above to add the additional nodes in there, and this will work across your farm. Next piece that we'll have is we'll actually stand up our virtual adapters. So this will add all of my respective virtual adapters. And I've got see how I have two SMB virtual adapters? These are going to be used for storage spaces direct. And you're asking yourself, okay, well, why are you creating two adapters? Well, the reason is very simple. I have two switches. I want one of these virtual adapters to go through switch 1, and I want another one to go through switch 2. So on the physical card, I've actually got two ports on there. One is plugged into switch 1, the other one's plugged into switch 2. There's a little trick that we can use through PowerShell to actually tell the adapters which direction to go. So we'll go ahead and stand up those virtual adapters. Come in here. This is kind of neat because we can watch the virtual adapters being stood up. And there we go. So there are virtual adapters. They're already created for us. So you can see right here that our virtual adapters are actually bound off of the virtual switch, but I didn't create a management adapter, so it doesn't look like there's one inside of the UI, but there is a virtual switch there. We could go check it in Hyper-V. We'd see it. I called the virtual switch VSW01. And as I come back and there we go. Sorry, I have a little bit of lag connecting into my lab here. So I got VSW01 as my virtual switch, and then these are the respective virtual adapters. The next step that we have is, do you guys remember how we took a look at those VLANs that we had set up in the top of rack switch configuration earlier? This next line of PowerShell is actually what tells my Hyper-V virtual adapters to match that config that we have. Oops, sorry, I went too far here. Grab this, and let's go ahead and let's set those VLANs up. All right. Give this a second to run. Next thing that we'll do is we'll actually go check to see what our VLAN configuration looks like here. So this is just going to give us a list of the actual VLANs that are now configured on the box. Perfect, that looks good. So I think we had 616 through 619 configured. 0 is just our default VLAN for the management interface. Now the next piece of this is actually really important. We have to actually disable what's called we have to disable flow control on those Mellanox adapters. And the reason is that you can't run flow control and priority flow control on the same adapter. So we have to turn off flow control. This would be the same as me going into the network properties of that particular adapter and disabling it there, but I just like to do everything through PowerShell. So that's done. Next piece that we're going to do is actually create the affinity between those adapters. So remember earlier I said that I want to create the adapters in such a way that we want to take the interface SMB1 and I want to push that out through a particular physical port or physical adapter. So that's what we're doing here. So I can actually take these next two lines and I can tell the switches to the virtual adapters to physically go through these particular physical adapters. So the virtual adapter SMB1 on each of the servers is going to go through Ethernet 5, and SMB2 is going to go through Ethernet 6. Now make sure that these are actually lining up properly on each of your nodes when they were built, because Windows is notorious for confusing that order of the adapters as they come in. So port 0 adapter on your physical machine is not necessarily always going to be Ethernet 5. So just make sure you double check that. All right, that's looking good. That just takes a second to run. We're almost there, guys. Maybe another 2 minutes and we will be there. We will be done. Okay, so the next piece here is we want to just take a look at our virtual adapter configuration that we just built from PowerShell's view. We already saw it from the UI through the networking control panel applet, but let's actually take a look at this through PowerShell. So we just run get VM network adapter. All right, and so now I can see that I've got my SMB adapters that are ready to go in here, and I've got those spreading across both nodes. The configuration looks pretty good. The other virtual switch was already there, the embedded vSwitch. So that's just a management vSwitch that I had configured from before. And so you would have to configure that obviously on your side. But I just needed to leave that, otherwise I would lose connectivity through my RDP session that I have here. Okay, so the next piece that we're going to do is we're going to run a command called netstat-xan. Netstat-xan is used to see our RDMA connections that are set up on these particular nodes. So let's go ahead and let's run that on each of the respective nodes. And blank. Folks, if you see this in your environments, you're running netstat-xan and it is blank, it's because you forgot to enable netadapter RDMA. Okay, so just because you went through all those settings above, configuring your data center bridging, doing all that work, if you forgot this little line, netadapter RDMA, it's not going to work for you. So first thing that we're going to do here is we'll just check this. We'll see if it's actually enabled. We can see that it's actually not enabled on those adapters. It's enabled on the Mellanox adapters, but it's not enabled on the individual adapters. So if on your boxes you just do this, go get dash netadapter RDMA. This will return a list of all the adapters and their configs. Look at this. See, SMB 1 and 2 are set to false right now. And because those two are set to false, we went through all this work to configure netadapter RDMA, and it's not going to be working. So this is what the next line is going to do for us. So we'll actually turn that on, okay? Turn that on those. Now we can see that they're set to true. Making sense? Now we'll run netstat-xan again. And now we have sessions starting to listen. Even without having storage spaces direct configured at this point in time, things are actually looking like they're kicking in and working for us. So this is what you should start seeing when you've configured everything properly. The next thing you can do is just see if there's a couple of performance counters that start to engage. So there's actually RDMA performance counters. Now, right now, for this particular config, nothing has been established yet from an RDMA connectivity perspective. So you won't see anything. But once we have storage spaces direct configured, you'll start to see these connections and counters go up. Okay, so everything's looking good for me so far. All right, so the next thing that we'll do is we'll just validate the VLANs. Let's make sure that everything looks good. Fantastic, I've got my VLAN set up properly. And then the last thing that we want to do, in order to take and in order to get those VLANs to kick in for us, you actually have to restart the network adapter. So that's like going disabled and enabled on each of the network adapters. So we'll go ahead and do that. This is going to actually kick in those connections for us. And the last thing we're going to do is check some IP addresses. We'll configure some IPs on those, and then we're good to go. So right now, what we should see is on each of those virtual adapters that we created, they should have an automatic private IP address configured. Now I see some do and some don't. So that's my production. That was already there. But see, like the management interface, it's got a 169.254 automatic private IP. So what we want to do next is actually put our IP addresses on there. Now, this is one of the most painful parts of configuring infrastructure like this, is actually defining your IP addresses and configuring them properly. So we've actually got this scripted out. So I'll just do the first node here, and then I could actually rip through the rest of the nodes. So go ahead and configure those IPs. I'll do it on the rest of the nodes. So this will do node 2. Okay, all the IPs are set. I actually had this set up for 4-node lab 4, but change that. And this is where we're going to probably actually wrap up this particular demo, is validating that we have some good network connectivity. So now you can use test network connections. Test network connections, a glorified ping inside of PowerShell. And we'll actually make sure that this comes back and is working for us properly. So we can see that ping success is true. See the other ones pop up, and then we're good to go. All right, so that's going to wrap up our first set of demos, which was building the networking stack and core infrastructure. The next set of demos that we have, we've got a few final minor configurations to go through. Then we can actually set up our failover Windows cluster and the rest of the underlying infrastructure.